In this video, we are going to go over applications with radicals and rational exponents. So in this first word problem, it says the velocity of a free-falling object, given that v equals the square root of 2gh, where h is the distance in feet the object has fallen, and g is the acceleration due to gravity in feet per second. The value of g depends on your altitude. If an object hits the ground with a velocity of 25 feet per second, from what height was the object dropped in each situation? All right, so from the initial paragraph, let's talk about what we know. So I know that my velocity is 25, so that's what I'm going to sub in for v. And then it looks like in each situation they're giving me a g. And so that means what I'm solving for is my h. So the equation I'm going to be using, like I said, is plugging in 25 for v, and it's going to be 2gh. Right now it says if you're standing on Earth, the gravity is 32 feet per second. So I'm going to plug in 32 for g. So I'm going to have 25 equals the square root of 2 times, instead of g, 32 times h. And so now I need to solve for h. So in order to get what's inside the square root, well, actually first let's multiply 2 times 32. So I'm going to have 25 equals the square root of 64h. Now to get to that 64h, I need to get rid of the square root. And to get rid of a square root, we're going to square and we do it to both sides. So when I do that, I'm going to get 25 squared is 625 is going to equal 64h. Then to finish getting the h alone, I'm going to divide by 64. And I'm going to get roughly 9.7656. It's about, we could also round it to 9.77 if we wanted to. Feet is the object, the height the object was dropped from. All right, let's look at number 2, or letter B. Now it's saying we're standing on the moon, so our gravity is only 0.009 feet per second. So we're going to use the same formula we did in A, except for G, I'm going to plug in 0.009, and now we're going to solve for H. So 25 is going to equal the square root of, well, 2 times 0.009 is going to give me 0.018 h. And again, just like above, to get rid of the square root, I'm going to need to square both sides. And so when I square 25, I get 625 again. When I square a square root, I'm just going to get what's underneath the square root. Now to finish getting h alone, I'm going to divide by 0.018 to both sides. So I'll get the height that the object was dropped from is approximately 34,722.22. So 34,722.22 feet. All right, let's look at the second problem. So it says, when you look at the ocean, the distance in miles you can see to the horizon is modeled by this equation. D equals 1.22 square root of A. And A is the altitude, or the feet you are above sea level. So it wants to know at what altitude, so what does A equal when you can see for 61 miles. So I'm going to take the formula, or the equation that they gave me. I'm going to substitute 61 in for D, and then I'm going to solve for A. So in order to solve for A, I want to get this A alone right here, this square root of A. So to do that, I need to divide by this 1.22. I'm going to divide because 1.22 is right up against that square root, so I know that they're being multiplied together. And so to undo that multiplication, we're going to divide. So I'll be left with the square root of A on this side, and on the right side, when I do 61 divided by 1.22, I'll be left with 50. Now, to get the A alone, the A is inside a square root, and to get rid of the square root, I'm going to square both sides. And so when I do 50 squared, I'm I'm going to get 2,500 is what A would equal. So the altitude would be 2,500. Well, my altitude is in feet, so feet.